to look at what's called the work energy theorem, where we're going to be putting together the kinetic energy formulas and the potential energy formulas. So this looks like a lot, but the top line, we said that the net work is the initial potential energy minus the final. We also said the net work is the final KE minus the initial KE. So we can actually put all of that together. So if we know that this equals work and this equals work, we can say that those are equal to each other. Or we can also say that the initial KE and PE added together equal the final KE and PE added together. And we can substitute in those equations for KE and PE. So initial KE 1/2 mv squared and initial PE mgh equals final 1/2 mv squared and final mgh. This last equation I would write down on my equation sheet. Now, one thing to notice, if you're looking at the same object throughout, they don't necessarily have to tell you the mass because the mass would cancel out in all these. They probably will most of the time, but don't panic if they don't give you a mass. So if we look at just in terms of KE and PE, not worry about 1/2 mv squared or mgh, if we go throughout this system, it starts out 0 plus 40,000 equals 40,000. At this point, we've got 20 plus 20,000, again, equaling 40,000. So everywhere along the path, adding these together is going to give me 40,000. The lowest point, the PE equals 0, so the KE is 40,000. The highest point, the KE is 0, so the PE is 40,000. But all the way throughout, between the highest and the lowest, those two will add together to give me 40,000. And you're going to be able to use this on a lot of the problems throughout. So if we look at this, we've got a pendulum swinging. So if we just look at A and D, those are at the same height. So A, the KE would be 0 and the PE would be the 2.4. B, if KE is 2, then that means the PE has to be 0.4. At C, that looks like it's the lowest point. If PE is 0, then KE would have to be 2.4. Now if we look at this, we've got different points on our path. So first we need to identify highest point because KE is 0, so our total is going to be 100 throughout. So this is the lowest point. So here the PE should be 0 and the KE should be 100. And it says, what's the velocity? Well, if we know that the KE is 100, then we can use our 1/2 mv squared to determine what the velocity is. So at G, we know that KE equals 100 because PE equals 0. We can say that that equals 1/2 mv squared, and we can solve for V. Now, they would have to give us a mass, of course, to find this, but we could solve for velocity, and you would do this throughout. So maybe at this point, if the total has to be 100, then here KE would be 50, and again, we would use 1/2 mv squared to find velocity. At this point, the height is the same, so again, C and D will be 50. And then here, we're at the lowest point, so PE will be 0 and KE will be 100. What about on this one? So we've got just velocities and height. So what we can do is look at what's initially happening and then determine what the final velocity would be. So let's look at initial PE would be, we're going to say initial side and final side. So initial height we've got mgh plus 1/2 mv squared is going to equal final mgh plus final 1/2 mv squared. So we don't have a mass here, but they'll all cancel out because mass is going to be the same throughout. So here we've got 9.8. The initial height is the 39.8 plus 1/2. And the initial velocity is at 36.7. We're going to square that. So that's going to equal, and then on this side, 9.8. The height here is 0 plus 1/2. And then we're looking for the final velocity. So if we calculate this, 9.8 times 39.8, this gives me 390.04 plus 1/2 times 36.7 squared gives me 673.45. So this added together gives me 673.45 plus 390.04, 1063.49. Well, this is going to cancel out and be 0, so equals 1/2 b squared. So divide that, divide this by your 0.5, and then take the square root, and it's going to tell us that the velocity equals 46.12 meters per second. What about this situation? So what can we tell about this? Well, first of all, this guy's at the bottom, so his P is 0. This guy's at the top, so his KE is going to be 0. So we can find at this point, they've given us enough to find KE. So we can do KE equals 1/2 mv squared. So we'll do 0.5 times the mass of 60 times 8 squared. So it says 1920, which means that PE up here should be 1920. Now at this point, he's 1 meter high. So we could do mgh to find his PE. So mass is 60 times 9.8 times the height of 1. So PE is 588 here. So then we can take the 1920 minus 588, because these two have to equal the 1920, and that gives us a KE of 1332. And this says find the velocity. So we're going to take that 1332 and set it up equal to 1/2 m v squared to solve for our v. So 1332 divided by 0.5. And then the square root gives us a velocity of 51.6. Okay, so here's what a problem might look like. A diver weighing 750 newtons. So let's go ahead and divide that by 9.8 to get his mass. So his mass, divide this by, come on thing, divide by 9.8. So his mass is 76.5 kilograms. He drops from a board 10 meters above the surface of the pool. Use the conservation mechanical energy to find his velocity 5 meters above the surface of the water. So we're going to use initial side and final side. So 1/2 mv squared initial plus mgh initial equals our final 1/2 mv squared plus mgh final. Okay, so let's fill in what we know. We know we've got 1/2. His mass is the 76.5. It tells us he drops from the 10 meters above the surface of the pool. At this point, he's not moving, so our velocity here is 0. Plus mass 76.5, 9.8, and then our height here is 10. On our final side, we're looking for his velocity. So we're looking for v. So 1/2, his mass is 76.5. We're looking for that v. So mass 76.5, 9.8, and his height now is 5 meters above. Okay, so let's solve. This is going to cancel out. So the initial side is 76.5 times 9.8 times 10. So this side equals 7,497. And then over here, we simplify. We've got 0.5 times the 76.5, 38.25 v squared plus 78.5 times 9.8 times 5. So 3748.5, 3,748.5. So then we solve for the v. So we're going to take the 7,497 minus the 3,748.5, divide it by the 38.25, and then square root. So the velocity ends up being 9.9 meters per second squared. Not squared, sorry, just meters per second. So this last step, just to clarify, we took this, subtracted that, divided by the 38.25, and then took the square root. Last one. So we've got a child, mass of 20, takes a ride on a slide of a height 6 meters. The child starts from rest at the top. Find the speed of the child at the bottom. So initial side 1/2 mv squared plus mgh. And then our final side 1/2 mv squared plus mgh. Okay, so he is starting from rest. So that's going to cancel out because his velocity is going to be 0. He's going to be at the bottom, so his height afterwards will be 0. So that's going to cancel out. So we just have the initial PE is going to equal the final KE. So let's plug in mass of 20 times 9.8, height of 6 equals 1/2 mass of 20 v squared. So if we solve for v, this side is 1,176 equals 10v squared. So 1,076 divided by 10 square root v equals 10.84 meters per second. All right, so that's conservation of energy.